Good day, ladies and gentlemen. Welcome back to the Insight tutorial channel, where insights meets excellence. So in today's video, we'll be continuing our organic chemistry revision series, where in the last part, we did 50 organic chemistry questions. And in today's part, which is the part 2, we will be doing another 50 organic chemistry questions, which will be very, very beneficial to your exams. So sit back, relax, get your pens, your jotters, and get ready to learn with us. Any questions you have, please put it down in the comment section and let's go. So before we get into today's work, I would love to re-emphasize that to further test your knowledge, after every question is read, you pause the video, do the answering by yourselves before you continue the video. So let's get right into it. Question 1. The maximum number of electrons that can occupy a single atomic orbital is A1, B2, C6, and D8. Now, the correct answer is B2, right? Now, for this particular question, we'll be following the Pauli exclusion principle, which says that an orbital can only occupy 2 electrons of opposite spin. So an orbital is only liable to occupy 2 electrons. That's the maximum number of electrons that can be in an orbital. Now, if you want to look at the p subshell, the p subshell has 3 orbitals. The p subshell has 3 orbitals. So now, that would mean that the maximum number of electrons the p subshell can occupy would be 3 times 2, which is 6 electrons. Reason being that one orbital can only occupy 2 electrons. So if it has 3 orbitals together will occupy 6 electrons. So the p subshell can occupy maximally 6 electrons. That's for option C. But the question is maximum number of electrons that can occupy a single atomic orbital. According to Pauli exclusion principle, it is 2. So B is our answer. Alright, so let's go on to the next question. The functional group of CH3COOH is A. hydroxyl, B. carbonyl only, C. ethyl, D. carboxyl. Alright, so we'll take each functional group one by one. The hydroxyl functional group is denoted by OH alone. Just OH. Now, secondly, the carbonyl functional group is C double bond with O. And I did say that carbonyl compounds are compounds that have C double bond with O as the only functional group. So this is a carbonyl functional group. And that is not what we have here, right? Now, an ethyl, for the functional group for ethyls is R, O, and R prime, where we have 2 alkyl groups connected by oxygen. But then when we have a carboxyl group, I'll come over here. The carboxyl group is basically hydroxyl group plus a carbonyl group. And that's how we have an hydroxyl group. So it looks something like this. C double bond with O and single bond with OH. And that's why we have COOH. So a carboxyl group, which is peculiar to carboxylic acid, is the functional group in CH3COOH. So that is the answer, the carboxyl group. Alright. So, next question. 2 compounds that are non-superimposable mirror images are A. diastereomers, B. conformers, C. enantiomers, D. constitutional isomers. So, the correct answer is enantiomers. Enantiomers are non-superimposable mirror images of each other. Non-superimposable meaning that you cannot place them on top of the other. So, what that means is, what one element or what one compound has on the right, the other compound should not have that same thing on the right. So when you superimpose them, they will have different things at different points. That means they are non-superimposable, right? So that is what enantiomers are. Enantiomers are non-superimposable mirror images. Now, diastereomers, which is option A, are not mirror images. They are stereoisomers with more than one chiral centers, but they are not mirror images of each other. Alright? Conformers are basically stereoisomers that we can rotate the configuration around the double bond. Right? And then constitutional isomers are basically isomers that differ in the connectivity of atoms. Not just spatial arrangement, but also in the connectivity of atoms. Right? So the correct answer is enantiomers, which are compounds that are non-superimposable mirror images. Alright, so to the next question. The purpose of sodium in Lassinus test is A. convert covalent nitrogen, sulfur, and halogens into ionic sodium salts. B. Oxidize the sample. C. Neutralize acid. D. Add color. Right. So the correct answer is A. Convert covalent nitrogen, sulfur, and halogens into ionic sodium salt. Now the concept is sodium acts as a reducing agent, right? And it converts these covalent compounds, nitrogen, sulfur, and halogens, into ionic sodium salts that are soluble, right? In this test, it converts them into ionic sodium salts that are soluble, right? Now, it does not oxidize the sample because it is a reducing agent, it's not an oxidizing agent. So it does not oxidize the sample. It does not neutralize the acid because in this stage of the test, there is no acid to neutralize, right? And secondly, it does not add color because sodium creates or forms colorless extract. So the ionic sodium salts that will be formed from nitrogen, sulfur, and halogens are colorless. So it does not add color. So the correct answer is convert covalent nitrogen, sulfur, and halogens into ionic sodium salt. All right. Now, the next question. Anti-bumping granules are added during distillation to A. Raise the boiling point. B. Cool the vapor. C. Catalyze the reaction. D. Ensure smooth, even boiling. Now, first of all, what exactly is bumping? Now, distillation is a separation technique where you separate two liquids with different boiling points, where you separate two miscible liquids with different boiling points. Now, there's also a scenario that as you are boiling these liquids to their different boiling points, there will be bumping of the liquids. Now, what that means is some liquids will begin to splash against the walls of the laboratory container, which is not good enough for collection, right? So the function of the anti-bumping granules is to ensure smooth and even boiling, where there will be no splashing of molecules or splashing of liquids on the walls of the laboratory apparatus used in boiling. So the answer is D. Ensure smooth, even boiling. Not raise the boiling point, not cool the vapor, also not catalyze the reaction, but to ensure smooth and even boiling. All right, next question. In IUPAC nomenclature, substituent prefixes are listed in A. Order of size. B. Alphabetical order. C. Order of appearance. D. Reverse order. Now, prefix is basically what is written before the parent name of the organic compound, right? So for example, if there is a substituent, prefix is basically the name of the substituent written before the parent name. For example, chlorobutane. Chlorine is the substituent, so chloro is the prefix, butane is the parent name. So supposing you have more than one prefix, for example, you have a compound where there's more than one substituent, like there's bromine, there's chlorine, there's also fluorine, sometimes there could be nitrogen, right? So all these substituents has to be written as prefixes to the parent name. So this question is asking, how are these prefixes listed? Is it in order of size, alphabetical order, order of appearance, or reverse order? The correct answer is alphabetical order. So the prefixes are written in alphabetical order. So supposing we have bromine, chlorine, and nitrogen, which will be written as bromo, chloro, and nitro, right? These prefixes will be written in alphabetical order. So B comes before C, so B will be first. C comes before N, so chlorine will be second, and nitrogen will be last. That is how it works. All right. All right. Next question says a dihedral angle between the front and back carbon to hydrogen bonds in staggered ethane is A. 60 degrees, B. 0 degrees, C. 90 degrees, D. 120 degrees. All right. So let's demystify some concepts. Now, first of all, where this dihedral angle comes in is when we're talking about eclipse conformation, which is a type of conformation in stereochemistry. All right. Now, in this conformation, there are two types of angles. There's the staggered angle and there's the overlapping angle. So now, in the staggered angle, which is what we're asked to find, the angle is 60 degrees. Right? So in a staggered angle of the eclipse conformation, which is the dihedral angle, it is 60 degrees. But then in the overlapping angle of this eclipse conformation is 0 degrees. The 0 degrees is for the overlapping angle. Alright? But then 60 degrees is for the staggered angle, the staggered dihedral angle, which we were asked. 90 degrees is not part of this talk that we're talking. 120 degrees is also not part of the eclipse conformation. Alright, so the correct answer for the staggered ethane is 60 degrees. Alright, next question. The geometry about each carbon in the ethene or ethene molecule is A. Tetrahedral, B. Linear, C. Trigonal planar, and D. Pyramidal. So they're basically asking us the shape of the carbon atoms in ethene. Right? Now we need to know that ethene is first of all an alkene. And alkenes have double bonds, right? And now alkenes are sp2 hybridized. They're sp2 hybridized, and they also have a bond angle of 120 degrees. So all these are properties of alkenes. So we're asking the shape of the carbon molecule in this alkene, and the correct answer is trigonal planar. The shape of alkenes, or the 120 degrees bond angle, gives a trigonal planar shape. Tetrahedral is for alkanes with a bond angle of 109.5 degrees and sp3 hybridized. Linear is for alkynes with a bond angle of 180 degrees and sp hybridized. Pyramidal is not necessarily among our concept of hydrocarbon shapes, so that's why we're not going to look into it. But the correct answer for ethene, which is an alkane, the bond angle is 120 degrees, the shape is trigonal planar. Alright? So the next question, controlled oxidation of primary alkanols first gives A. ketone, B. aldehyde, C. ester, D. ether. Now, we did say in part 1 that the oxidation of alkanols of primary alkanols can be partial and complete. So now, partial oxidation of primary alkanols gives a product, and then when you further oxidize that primary alkanol, it gives another product. So this question is asking, what does it give first? That's in the partial oxidation. So partial oxidation of primary alkanols will first of all give an aldehyde, Partial oxidation of primary alkanols will first of all give an aldehyde, that's an alkanol. Now, a ketone is formed from the oxidation of secondary alkanols. Alright? Now, complete oxidation of primary alkanols gives alkanoic acid or carboxylic acid. But we're not asked that. So partial oxidation, that's what the primary alkanols will give first after oxidized, is aldehyde. Esters are formed from the condensation of carboxylic acid and alkanols. It's very important. Esters are formed from the condensation of carboxylic acid and alkanols, right? And then ethers, we know what ethers are. Ethers are formed from two alkyl groups connected by oxygen. So the correct answer here is aldehyde. Alright, the next question. A green flame when a sample of copper wire is heated indicates A. Metal, B. Nitrogen atom, C. Sulfur atom, D. Halogen. Now, this test is the Beilstein's test, right? And the concept is when a sample of copper wire is heated, right, and it gives off a green flame, it is going to indicate that there is a halogen in that there's a halogen that's been given off. All right, so a green flame basically indicates a halogen in Beilstein's test. That's the name of this test, burning copper wire to give a green flame. That's how easy it is. All right, so the next question, a compound with stereocenters and an internal plane of symmetry is A. a meso compound, B. a racemate, C. a dextrorotatory compound, and D. a pair of enantiomers. The correct answer is a meso compound. A meso compound has more than one stereocenters or chiral centers and has an internal plane of symmetry. So we did say that this internal plane of symmetry is what causes it to not have optical activity. It is not a racemate. A racemate is a combination of two enantiomers, right? And since these enantiomers are mirror images of each other, because of the outer plane of symmetry, due to the different rotations, both of them will cancel out the optical activity of the mixture. So a racemate does not have optical activity, but it is due to outer plane of symmetry, right? Dextrorotatory means it will rotate light to the right side, not to the left. Dextrorotatory is to the right side, levorotatory is to the left side, right? Now, a pair of enantiomers are basically two non-superimposable mirror images of each other. So the correct answer is meso compound, a meso compound which has several stereocenters and an internal plane of symmetry. All right, next question. Which of the following is an ether? Right. So first of all, let's remind ourselves what an ether is. An ether is two alkyl groups connected by an oxygen. Right. So we're looking out for two alkyl groups connected by an oxygen. So the first one says CH3CHO. Second, B says CH3COOH. C CH3OCH3, and D CH3CH2OH. So for the first one, we can take note of all the functional groups. And for the first one, we can say that the functional group is CHO. And CHO is the functional group for alkanals or aldehydes. Right? So that is not the ether. The next one, which is B, is CH3COOH. And the functional group is the carboxyl functional group, which is the functional group for carboxylic acid or alkanoic acid. Right? Now C says CH3OCH3. Now we can see that this is an alkyl group, CH3, which is methyl. This is oxygen, and this is another alkyl group. And we did say an ether connects two alkyl groups with oxygen. So this is the correct answer. Alright, so CH3OCH3 is the ether in this option. This says CH3CH2OH. We know that OH tells us that it's what? An alkanol or an alcohol. So this is the functional group of alkanols. Alright, so next question. The number of sigma bonds in a molecule of ethyne C2H2 is A1, B5, C2, and D3. So first of all, let's establish that in covalent bonds, a single covalent bond has one sigma bond, a double covalent bond has one sigma bond and one pi bond, a triple covalent bond has one sigma bond and two pi bonds. So now in ethyne, we know that ethyne is made up of triple bonds, right? Alkynes are, the functional group of alkynes is a triple bond. So in ethyne, this is the structural formula for ethyne. Alright? Carbon triple bonded with carbon and then two hydrogens by the side. So remember, in single bonds, there is a sigma bond. In triple bonds, there's one sigma bond and two pi bonds. So if we want to count the number of sigma bonds only, this is a single bond. So this gives us one sigma bond. This is another single bond. We have one sigma bond. And in this triple bond, there's one sigma bond and two pi bonds. So from this triple bond, we have one sigma bond. So together, that gives us three sigma bonds. Alright? So in total, there are three sigma bonds in ethyne. Right? So you just need to know that single covalent bond has one sigma bond, double covalent bond has one sigma bond, one pi bond, and a triple covalent bond has one sigma bond and two pi bonds. Alright, so the next question. The best method to purify a solid that sublimes on heating is A. Distillation, B. Sublimation, C. Extraction, D. Filtration. Answer speaks for itself. The question says to purify a solid that sublimes. So the best method will be what? Sublimation. Not extraction, not filtration, not distillation. Distillation, we know that is to separate two miscible liquids with different boiling points. Extraction is for extracting solvents from a solute, right? Now, filtration is for removing a solute, an insoluble solute from a solvent, right? So the best method to purify a solid that sublimes is sublimation. All right. Next question. The compound HCOOH is called A. Methanoic acid, B. Ethanoic acid, C. Methanol, D. Methanol. Now, first of all, the functional group here is COOH, which is peculiar to alkanoic acids, right? So now, is it methanoic acid or ethanoic acid? The answer will be methanoic acid. The reason being that it has only one carbon atom. If it was two carbon atoms, just like CH3COOH, this is two carbon atoms, and that is ethanoic acid. But this has only one carbon atom. It's the simplest form of alkanoic acid called the methanoic acid. Methanol would be for alkanals, right? And methanol would be for alkanols. So methanol would be this HCHO, right? And methanol would be CH3OH, right? These are the simplest forms for alkanals and alkanols. So the correct answer is methanoic acid, HCOOH. All right. So the next question. The Dumas method measures nitrogen as the volume of A. Ammonia, B. Carbon dioxide, C. Hydrogen, D. Nitrogen gas. Now, Dumas method is a qualitative analysis method, or quantitative analysis method rather, to notify the quantity of nitrogen in a substance or in an organic substance. So now how it works is that organic substance is passed through heated copper 2 oxide and carbon dioxide. So the concept is the heated copper 2 oxide will cause there to be effervescence of nitrogen gas, and this nitrogen gas is collected to measure the volume of nitrogen. All right, so what you are using to measure the nitrogen volume in Dumas method is nitrogen gas, not hydrogen, not carbon dioxide, not ammonia. All right, next question. Cis-trans isomerism arises due to a chiral carbon, B, a lone pair, C, restricted rotation about a carbon double bond to carbon ring, D, hydrogen bonding. All right, so now do you know that the cis-trans isomerism is geometrical isomerism, right? Which is as a result of the position of substituents in a double carbon to carbon ring. For example, A, B, B. Now, when the substituents are side by side, it is a cis isomerism, and when the substituents are opposite each other, it is the trans isomerism. Now, this is as a result of the restricted rotation about a carbon to carbon double ring or double bond ring, right? Reason being that this is a type of configurational isomerism where if you want to alternate the substituent here, you would have to break the double bond and then now alternate the substituent. So this restriction on the rotation is what causes there to be the cis and trans isomerism, where substituents can only be side by side or opposite each other, which is the cis or trans isomerism, right? So the answer is restricted rotation about a carbon double bond to carbon ring. Now, next question. The hybridization of nitrogen in ammonia is A, sp, B, sp3, C, sp2, and D, sp3d. All right, so first of all, if we have nitrogen, right, nitrogen has 5 electrons. Now, it has a lone pair of electrons like this that does not take part in any bonding. Now, the other 3 electrons bond each to hydrogen, all right? So we now have 3 bonds formed to hydrogen atoms each. All right, so now this bonding to hydrogen atom and the lone pair gives it a form of a tetrahedral shape where there are 4 different forms, right? So this gives it a form of a tetrahedral shape. And now, because of this tetrahedral shape, we know that the tetrahedral shape is for molecules that are sp3 hybridized. So the correct answer here is the hybridization of nitrogen in ammonia is sp3. sp is for linear molecules, which is 180 degrees. sp2 is for trigonal planar, which is 120 degrees. sp3d is not among what we're talking about, right? So the correct answer is sp3 hybridization, which gives it a type of a tetrahedral shape. Okay. So to the next question, which reagent gives an orange precipitate with both aldehyde and halogen? A, 2,4-dinitrophenylhydrazine, B, Tollens reagent, C, iron 3 chloride, D, sodium hydrogen carbonate. Now, the correct answer is 2,4-dinitrophenylhydrazine. This is basically used to test for aldehyde, right? Where it reacts with the carbonyl group in aldehydes and ketones, and it will give an orange precipitate. Right. Now, Tollens reagent is a specific test for aldehydes. 2,dinitrophenylhydrazine gives an orange precipitate specifically with aldehydes and also ketones, right? Tollens reagent is very, very specific for just aldehydes. Iron 3 chloride is used for phenols. It's used to test for phenols. Sodium hydrogen carbonate is used to test for carboxylic acid. So the correct answer here is 2,4-DNPH or 2,4-dinitrophenylhydrazine. Now, next question. Conformational isomers is interconverted by A, breaking a bond, B, reflection, C, rotation around a single bond, D, oxidation. Now, the correct answer is rotation around a single bond. Conformational isomerism, you don't need to break the bond before you can rotate or interconvert the substituent. unlike configurational isomerism, where there needs to be a bond breaking before there is reorientation or interconversion. In conformational isomerism, you can just rotate around a single bond, not breaking of bond, not reflection, and also not oxidation. All right, next question. In combustion analysis, carbon is estimated as carbon dioxide absorbed by A. Calcium chloride, B. Water, C. Silver nitrate, D. Potassium hydroxide. So in this combustion analysis, what happens is that there is combustion of an organic compound and there is effervescence of carbon dioxide. And this carbon dioxide is absorbed by a particular material and then now weighed. So, and then now qualified, yes, because it's qualitative analysis. So now, the substance that is used to absorb the carbon is potassium hydroxide, because that carbon that's given off will be acting as an acid. It has a weak acidic characteristic, which reacts with potassium hydroxide that is a base, right? And this will now give us a product. So that's a qualitative test for carbon dioxide, not calcium chloride, not water, and also not silver nitrate. All right, so the next question. A P subshell can hold a maximum of A 2, B 10, C 6, and D 14 electrons. The answer is 6 electrons, right? Now, we did say that an orbital can only house a maximum of 2 electrons. So there are 4 different subshells. There's the S subshell, P subshell, D subshell, and F subshell. Now, these 4 different subshells have different numbers of orbitals. Now, the number of orbitals in a subshell is what determines the number of electrons that subshell will have. So now the S subshell has only 1 orbital, the P subshell has 3 orbitals, D subshell has 5 orbitals, and F subshell has 7 orbitals. So now we did say that orbitals can only house 2 electrons. So that means the S subshell will house how many electrons? 2 electrons. The P subshell will house, since there are 3 orbitals, 3 times 2 is 6. So that's 6 electrons. The D subshell will house, since there's 5 orbitals, 5 times 6 is 10. So that's 10 electrons. And the F subshell, since there's 7 orbitals, will house 7 times 2 is 14 electrons. So the question we're asking is, the P subshell can hold a maximum number of 6 electrons. 2 is for S subshell, 10 is for D subshell, 14 is for F subshell. Alright, next question. A carbocation is A. Positively charged and sp2 hybridized, D. Negatively charged and sp3 hybridized, C. A radical, D. A lone pair species. Now, the carbocation basically is carbon with a positive charge. Now, the positive charge is due to the loss of an electron. Remember, carbon has 4 electrons, right? So now, these 4 electrons that carbon has enables it to have 4 different bonds. But then if we remove an electron and give it a positive charge, it can only have 3 different bonds. So now, when carbon forms these 3 different bonds, it has kind of a trigonal shape, right? Not a tetrahedral shape like normal because of the 4 bonds. But since it has lost 1 electron and it is now a cation which is positively charged, it has a trigonal shape. And remember, our trigonal planar is 120 degrees, right? Which is sp2 hybridized. So it is positively charged and sp2 hybridized. That is the answer. Now, negatively charged and sp3 hybridized is a carbanion or a carbanion. That's a negatively charged carbon atom. A radical is basically a group of atoms that have a single charge, right? And lone pair species are electrons in an atom that are not taking part in the bonding. So that's basically what it is. The answer is positively charged and sp2 hybridized, a carbocation. Next question. Ethers, unlike alkanes, dissolve in cold concentrated sulfuric acid because the oxygen is A. Weakly basic and forms oxonium salt, B. Oxidized, C. Halogenated, D. Polymerizes. Now, we remember that ethers is given by R, oxygen, and R prime, right? 2 alkyl groups connected by an oxygen group. So now, these ethers will dissolve in cold concentrated sulfuric acid because this oxygen that is here is A. Weakly basic and forms oxonium salt. The oxygen acts as a weak base which will react with sulfuric acid. Now, sulfuric acid is our normal H2SO4. So it will react with sulfuric acid and form an oxonium salt, right? So that is another distinguishing chemical property between ethers and alkanes. All right. So on to the next question. For a solvent extraction, the two liquids must be A. Identical, B. Equally dense, C. Both water, D. Immiscible. Now, for solvent extraction, we basically dissolve a solute or put a solute inside the two solvents that we want to extract. Now, the two solvents are together and we want to separate them from each other, but we're not using distillation, we want to use solvent extraction. So the concept is we'll dissolve a solute into that mixture, right? And from the distribution of the solute in the two mixtures, we're able to separate the two mixtures. Now, for this to be accurate, the two solvents has to be immiscible, right? So if they are immiscible, when we put the solute in, we will be able to see two distinct layers of solute, right, that we can separate. So the answer is, for solvent extraction, the two liquids must be immiscible. All right? Not identical, not equally dense, not both water, but what? Immiscible. Next question. The number of stereoisomers of a molecule with 4 different chiral centers is A8, B16, C4, D32. Right. So we did say that the relationship between stereoisomers, number of stereoisomers and chiral centers is 2 raised to the power of n, where n is the number of chiral centers. So now, this question says 4 different chiral centers. So that means we know that n is equal to 4 different chiral centers. So we now have that this will be written as 2 raised to the power 4, and 2 raised to the power 4 is what? 16. So the answer is 16 stereoisomers can be formed from a molecule with 4 different chiral centers. Alright, next question. The dipole arrow of a polar bond points from A, from partial positive atom to partial negative atom, B, from partial negative to partial positive, C, nucleus to nucleus, D, it has no direction. The correct answer is, so first off, the dipole arrow always points from the least electronegative to the most electronegative. Now, polarity, an increase in polarity is basically an increase in electronegativity. Alright, so the concept is the one that is least electronegative will carry the partial positive charge. It's not necessarily a positive charge, but since it is least electronegative than the other one, that means it is more electropositive. If it is least electronegative, it is more electropositive. So it will carry the partial positive charge. And the one that is most electronegative will carry the partial negative charge. So that means the dipole arrow is going to move from the one with the partial positive charge to the one with the partial negative charge, being that it is moving from the one with that is less electronegative to the one that is most electronegative. So the correct answer is A, which is from the partial positive atom to the partial negative atom. Not from the partial negative to the partial positive, not from the nucleus to nucleus, and definitely has a direction. It has no direction, because it has a direction, right? It moves from partial positive to partial negative atom. Alright, so to the next question. Which alcohol resists oxidation? Now, we did say that oxidation of alcohols is due to the removal of hydrogen atom on the carbonyl atom. Now, we did also say that the carbonyl atom is the atom that has the hydroxyl group, right? So if we draw a primary alcohol, it's an alcohol that the OH is on the primary carbon atom, right? And the primary carbon atom is connected to just one carbon atom. So we have something like this: OH, C, H, and H. Oxidation of this primary carbon atom will be removal of this, a hydrogen atom, or removal of the 2 hydrogen atoms, and we have an oxidation of the primary alcohol. But now, if we have a tertiary alcohol which is connected to 3 carbon atoms, there cannot be oxidation of this alcohol because there is no hydrogen atom to be removed for it to be oxidized. So the answer is tertiary alcohols. Tertiary alcohols resist oxidation. The answer is not primary alcohol because there's a hydrogen that can be removed. The answer is not secondary alcohols because there's a hydrogen that can be removed. And the answer is also not methanol, because methanol, the chemical formula for methanol is CH3OH. Now from the chemical formula, you can see that there is hydrogen available to be oxidized. So the answer is also not methanol. The answer is tertiary alcohol because there's no oxygen, so there's no hydrogen that can be removed to be oxidized. Right. So the next question, the empirical formula of glucose with 40% carbon, 6.7% hydrogen, and 53.3% oxygen is A, C6H12O6, B, CH2O, C, C2H2O2, D, CHO. Now, empirical formula basically refers to the simplest chemical formula that a compound can be expressed in. And there are a set of rules when you're solving for empirical formula. So let's get into it. Now, the three elements that we're using is carbon, hydrogen, and oxygen. So we spell that out. And the next thing is to write either the percentages or the masses of this compound. But in this case, we're given the percentages of these masses, of these compounds, or of these elements rather. So the percentage of carbon is 40, that of hydrogen is 6.7, and that of oxygen is 53.3. So these are the different percentages. Alright, so now the next step is to divide by the molar mass of the element or by the atomic mass of the element. Now, the atomic mass of carbon is 12, so we're going to be dividing the percentage by 12. The atomic mass of hydrogen is 1. The atomic mass of oxygen is 53 point. Sorry, the atomic mass of oxygen is 16, right? Oxygen as one element is 16. So now, doing these divisions, 40 divided by 12 will give us 3.33. 6.7 divided by 1 will give us 6.7. 53.3 divided by 16 will give us 3.33. Now, the next step is to divide by the lowest amount that we got, right? And from here, the lowest amount that we got is 3.33. So we divide everything by 3.33, 3.33, and 3.33. Please be sure to note down these steps because it's very, very important. Now, 3.33, we divide 3.33 and we have 1. 3.33 divided by 6.7 divided by 3.33 is 2.0, 2.01, which is approximately 2. And 3.33 divided by 3.33 is 1. So we now have that the ratio is 1 is to 2 is to 1. So that means carbon is going to be 1, C, hydrogen is going to be 2, H2, and oxygen is going to be 1, O. So this is the simplest formula for glucose with 40% carbon, 6.7% hydrogen, and 53.3% oxygen. The answer is CH2O, which is B, right? C6H12O6 is the main chemical formula for glucose, but it's not the simplest chemical formula for glucose. The chemical formula is the simplest possible chemical formula, which is CH2O. Alright, next question. The chair form of cyclohexane is free of A, all mass, B, carbon, C, hydrogen, D, angle and torsional strain. Now, the correct answer is angle and torsional strain. What that means is, in the cyclic form of cyclohexane, hexane is C6H14. Now, in the cyclic form of hexane, which is cyclohexane, the bonds between the carbon and hydrogen are close to each other. So that removes angle and torsional strain. Alright, it does not remove mass, or it's not free from mass, because it is still 6 carbon atoms and 14 hydrogen atoms. The mass is still going to be the same. It does not remove any carbon atom. It also does not remove any hydrogen atom. But what it removes is the distance between the angles of carbon to carbon and carbon to hydrogen bonds. So it is free of angle and torsional strain. So that is the correct answer. So next question. An aldehyde reduces Fehling solution to give A brick red precipitate of copper 2 oxide, B silver mirror, C violet color, D white precipitate. Now the answer is brick red precipitate of copper 2 oxide. Now in Fehling solution, the aldehydes will reduce that solution or that reagent to a brick red precipitate of copper 2 oxide. Now silver mirror is formed in Tollens reagent. Right? Aldehydes reduce Tollens reagents to give a silver mirror. Violet color is in phenols, right? When phenols react with iron 3 chloride, they give a violet color. Now, a white precipitate is not associated with Fehling solution or Tollens solution in any way, right? So the correct answer is brick red precipitate of copper 2 oxide. The next question. Which molecules has zero net dipole moment? A. HCl, hydrogen chloride, B. H2O, water, C. CO2, carbon dioxide, and D. NH3, ammonia. Now, the correct answer is CO2. Now, zero net dipole moment means there is no charge from the right or to the left. Now, if we look at CO2, it looks a bit like this. CO2 is a linear molecule. So the partial positive and partial negative charges, the rotations cancel out each other, right? So there's now a zero net dipole moment between the two of them because this is a linear molecule and the rotations cancel out. That's basically it. Not HCl, not H2O, and also not NH3. Now, the next question, the IUPAC name of CH3CO CH2 CH3 is A. Butanal, B. Butan 2-one, C. Butan 1-ol, and D. Butanoic acid. Let's expand this structure. So we have CH3, we have CO, right? We have CH2, and we have CH3. All right, so when you expand this structure, you need to always take into account that carbon cannot have more than 4 bonds. And we also took into account that oxygen cannot have more than 2 bonds, also cannot have less than 1 bond. So now as we can see, the functional group here is carbon double bond with oxygen, which is an alkanone, right, or a ketone. So we know that the parent name is going to be an alkanone. And the next thing to establish is the number of carbon atoms, which is 1, 2, 3, and 4. 4 carbon atoms. So the parent name is going to be what? Butanone. There's no substituent attached, so it's only going to be butanone. Now we now go on to ascertain the number which the functional group is on. So this is number 1, 2, 3, 4. We always number it from the side that is closest to the functional group to give the functional group the lowest number. If we number from here, the functional group is going to be on number 3. But as we're numbering from here, it's on number 2, right? So we now have that the functional group is on number 2. So it is butan 2-on. Butan, 4 carbon atoms, on alkanone, 2 on carbon 2. So the answer is butan 2-on. Butanal is CH, the functional group for alkanals is CHO, which is not this. Butan 1-ol, the functional group for alkanols is OH, which is not this. And butanoic acid, functional group for alkanoic acid is COOH, right? So our answer is butan 2-on. Okay, next question. A pair of sugars differing at only one stereocenter are A. Anomers, B. Enantiomers, C. Identical, D. Epimers. Now, the answer is epimers. Epimers are basically a pair of sugars that are different only in a stereocenter, that's in a chiral carbon. There's a change in the orientation around the chiral carbon. So these two sugars are said to be epimers. Now, anomers are different in the anomeric carbon. The anomeric carbon is always the carbon that is with the functional group. Alright? So anomers are different in the anomeric carbon. Enantiomers are non-superimposable mirror images of each other. And identical, we all know what identical is. Identical means that they're identical. And so the correct answer is sugars differing at only one stereocenter are called epimers. Right? So, next question. For a fixed volume of solvent, extraction is most efficient when done A. in one large portion, B. regardless of how it's divided, C. in several small portions, and D. with hot solvent only. The correct answer is in several small portions. Now, when you're extracting a solvent, now we did say that solvent extraction is for 2 immiscible liquids, right? Where we're going to put a solute and then we'll extract it depending on the distribution of the solid. The best way to do it is in small several portions, because with that we can accurately distribute and extract the solvent from the solute distribution. That's basically it. Not one large portion. If it's one large portion, it will not be as efficient and as accurate as small several portions. Alright, so now to the next question. The projection used to depict sugar configuration is the A. Fisher projection, B. Newman projection, C. Chaired diagram, and D. Wedge dash for conformers. Now the correct answer is Fisher's projection. Fisher's projection is used to depict sugar configuration. Newman projection is used to depict conformational relationship in organic structures. Newman projection is used to depict conformational relationship. Chaired diagram is used to show conformational arrangement or conformational 3-dimensional arrangement of stereostructures. And then wedge dash for conformers is basically used to show 3D arrangement in organic chemistry. 3D arrangement in stereochemistry is normally shown with the wedge dash for conformers. Alright, so next question. The electronic configuration of chlorine atom Z is equal to 17 is A 1s2, 2s2, 2p6, 3s2, 3p6, B neon 3s2, 3p3, C argon 4s1, D 1s2, 2s2, 2p6, 3s2, and 3p5. Alright, now first of all, we need to take note of the atomic number. The atomic number of chlorine is 17. Z is equal to 17. Z stands for atomic number. Alright, now basically the first thing that will help us to know if our options are correct is that the combination of the electrons in the electronic configuration should be equal to the atomic number. Reason being that the atomic number is equal to the number of protons, which is also equal to the number of electrons. So when we add up the electrons in our electronic configuration, it should give us what? 17. Now, if you look at the first one, but let's try to write the electronic configuration of chlorine first. Now, we're going to start from 1s2 because remember, once we said that to enter low energy levels first. Sorry, Aufbau's principle said that to enter low energy levels first and then to higher energy levels. So we'll start with 1s2, right? Then 2s2, 2p6. Now, together, this is 10 electrons. There's still 7 more electrons to be distributed. So from 2p6, we go to 3s2, and this is 12 electrons. There's still 5 more electrons. Remember, it's 17 electrons. So there's 5 more electrons to be distributed, and that will be 3p5. Because the p shell can house up to 6 electrons. So that's 3p5. So this is the electronic configuration of chlorine, which will be option D. Now, what this neon means is the electronic configuration of neon, which is 1s2, 2s2, 2p6, then 3s2 and 3p3. What this argon means is the electronic configuration of argon, which is 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. Right? That's basically the electronic configuration of argon. So we're saying that and 4s1, which is not the correct answer. The correct answer is 1s2, 2s2, 2p6, 3s2, and 3p5. If you calculate all the electrons above together, it will give us what? 17. That is the electronic configuration of chlorine. Alright, next question. Which compound is most acidic? A. Ethanol, B. Ethanoic acid, C. Phenol, D. Water. Now, when we are comparing compounds that have acid properties, for example, ethanol, ethanoic acid, and phenol, the 3 of them have acid properties. So how do we determine which one is most acidic? Now, when an acid reacts with water, or when an acid is dissolved in water, what it gives us is a conjugate acid and a conjugate base. Now, what determines the acidity is the stability of the conjugate base that is formed. So now, if the conjugate base is more stable, then the acid is stronger. If the conjugate base is less stable, then the acid is weaker. So weak acid give a less stable conjugate base. Strong acid give a much stable conjugate base. So between these 3, which would have the strongest or the most stable conjugate base? All right, and this conjugate base is stabilized by resonance. All right, so now the one that will be most stable is ethanoic acid. Ethanoic acid has a more stable or the most stable conjugate base amongst the 3 with acidic properties. So it is going to be the most acidic. Then the one that is second to the list is phenol. Phenol has a much more stable conjugate base than ethanol. So ethanol is the least acidic on this list. But the most acidic is what? Ethanoic acid, because it has the most stable conjugate base. This base is stable by what? Resonance. Alright. Next question. A racemic mixture can be separated by A. Optical resolution, B. Fractional distillation, C. Recrystallization from one solvent, D. Sublimation. Now, we know what a racemic mixture is. I said that racemic mixture is a mixture of 2 enantiomers. So the only way we can separate these 2 enantiomers is by separating them by their optical activity, which is optical resolution. Because remember, enantiomers only differ in their chiral centers and different in their optical activity. So when one rotates light to the right, dextro-rotatory, another will rotate to the left, levo-rotatory. But they are both mirror images of each other. So they have similar physical and chemical properties. So fractional distillation involves separating liquids with boiling point, right? We cannot use boiling point because both of them have similar boiling point. Recrystallization, the same thing. They have the same solubility. So we cannot use recrystallization. They have identical solubility. They also have identical volatile rates, because for sublimation the substance has to be volatile, right? And both of them will have the same volatile range, so we can also not use sublimation. So the correct answer is optical resolution, since enantiomers will have different optical activities. All right, next question. The type of analysis that identifies elements that are present, not amount, is A. Quantitative analysis, B. Gravimetry, C. Qualitative analysis, D. Titration. Now, the emphasis is on not the amount. It just tells us that we are looking for an analysis that shows the elements that are present, that's the constitution, but not the amount of what is present. And the answer is qualitative analysis. Qualitative analysis tells us the element or the organic compounds that are present in a substance. All right, so quantitative analysis tells us the amount of the substance that are present, right? Gravimetry is a form of quantitative analysis, so it still tells us the amount of the substance that is present. And titration basically tells us the amount of acid and bases, right? But the one that tells us the type of the compounds or elements that are present is qualitative analysis. All right, you do qualitative analysis by testing out their chemical and physical properties. That's how you'll be able to get the quality of what is there. That's the elements that are there, or the composition. So, next question. Phenol is more acidic than ethanol because the phenoxide ion is A. Less stable, B. Stabilized by resonance into the ring, C. Protonated, D. Free of the ring. I've already explained that the more acidic will mean more stability of the conjugate base, and the phenoxide ion is the conjugate base of phenol. When phenol is dissolved in water, it will give off hydrogen ion and phenoxide ion. So phenoxide ion is the conjugate base, hydrogen ion is the conjugate acid. So we said that the more acidic it is, the more stable the conjugate base is. So that means that the correct answer is its conjugate base, which is phenoxide ion, is stabilized by resonance into the ring, hence making it more acidic than ethanol. Ethanol, the conjugate base of ethanol, which is ethanoxide acid, would be less stable. That's why it is a weak acid than phenol, weaker acid than phenol. All right, so now next question. The bond angle in methane is A. 90 degrees, B. 104.5 degrees, C. 107 degrees, and 109.5 degrees. You should be able to attempt this question by yourself. The correct answer is 109.5 degrees, because we know that methane is an alkane, right? And an alkane is sp3 hybridized. An alkane also has the tetrahedral shape. So because of this, the bond angle is 109.5 degrees. All these other angles have nothing to do with hydrocarbons, organic structures, right? So alkanes have the bond angle of 109.5 degrees. Methane is an alkane, so its bond angle will be 109.5 degrees. Okay, so next question. The condenser cools the vapor most efficiently when water flows A. Top to bottom, B. Not at all, C. Bottom to top, D. Intermittently. Now, you need to know that in a condenser, when you're passing the vapor from the top of the condenser to the bottom of the condenser. Now, vapor is hot, right? So the concept is for water to cool that vapor efficiently, water has to go against the flow of the vapor. So if the vapor is coming from top to bottom, that means the water will have to flow from bottom to top. So the correct answer is C. Bottom to top. Reason being that the water has to flow counter current to the flow of the vapor, so that the temperature gradient will be high, and then we can now cool the vapor that is coming down. All right, so next question. An ester is formed when a carboxylic acid reacts with alcohol, releasing A. Hydrogen, B. Water, C. Carbon dioxide, D. An alkane. Now, what you need to know that is carboxylic acid and alcohol is basically like a neutralization reaction where we have an acid and a base. The carboxylic acid serves as the acid by liberating hydrogen ion. The alcohol serves as the base and liberates hydroxyl ion. So now what happens is that it's going to lead to the formation of an ester, which is an alkanoate, and liberation of water, just like a normal acid and base reaction, right? So it's not hydrogen, it's not carbon dioxide, it's also not an alkane. It releases water alongside the ester that is formed. Okay, next question. Anomers, alpha and beta glucose differ at A, C2, B, C3, C, C6, D, anomeric carbon, C1. Now, anomers always differ at the anomeric carbon, and for glucose, the anomeric carbon is C1. I did say that anomeric carbon is the carbon with the functional group. Glucose is an aldehyde sugar, so its functional group is going to be on carbon 1. Remember, the functional group for aldehyde is CHO, and this functional group is always on the carbon 1. And since the anomeric carbon atom is the carbon atom with the functional group, the anomeric carbon atom for glucose will be carbon 1. So anomerism is when there is a change in the orientation of atoms around the anomeric carbon atom, and for glucose that will be carbon 1. Alright, so next question. In the Carriers method, a halogen is precipitated and weighed as A, barium tetraoxosulfate 6, B, a sodium halide, C, silver halide, that's AgX, and D, day-free halogen. Now, in Carriers method, we use silver nitrate to decompose the organic compound, and then it's going to form silver halide, AgX, where X represents the halogen. It could be chlorine, fluorine, iodine, whatever halogen you're looking at, right? So there's going to be formation of silver halide because silver nitrate is used in the Carriers method, and that decomposes the organic compound to form silver halide. All right, so the answer is silver halide. All right, next question. Water's bond angle of 104.5 degrees is smaller than the tetrahedral angle of 109.5 degrees because oxygen has A, 2 lone pairs, B, 1 lone pair, C, no lone pairs, D, sp2 hybridization. The correct answer is 2 lone pairs. Now, what you need to know is that a decrease in the amount of lone pairs leads to an increase in the angle, because when there are lone pairs, the atom or the structure is smaller than when there are no lone pairs, right? So 2 lone pairs will lead to a smaller bond angle, which leads to a smaller structure. 2 lone pairs is 104.5 degrees. 1 lone pair will increase it a bit to 107 degrees, right? A structure with one lone pair will have a bond angle of 107 degrees, and then a structure with no lone pair, just like your tetrahedral or your sp3 hybridized structures, no lone pairs is going to be 109.5 degrees. They don't have any lone pairs. All the pairs of electrons, all the electrons take part in bonding. So no lone pairs will have a bond angle of 109.5 degrees. So you can see that as the lone pairs decrease, the bond angle increases. All right, sp2 hybridization is not the correct answer because water is sp3 hybridized. All right, but it's just that presence of lone pair will reduce the angle. Presence of lone pair will reduce the angle, but you can see that the difference is not that much. We have 104.5 degrees to 109.5 degrees. Right. So next question: what is the name of HNO3? A, nitric acid. B, nitric hydride. C, hydrogen 5 nitride. D, trioxonitrate 3. The correct answer is nitric acid. Now, nitric acid is also known as trioxonitrate 5. Trioxonitrate 5. This is because the oxidation number of nitrogen here, or the oxidation state of nitrogen here, is 5. Now, you can see option D is trioxonitrate 3. This is actually wrong because the oxidation state of nitrogen there is not 3, but it is 5. So it is nitric acid or trioxonitrate 5, not nitric hydride, not hydrogen 5 nitride. All right. So we're doing the last 2 questions in today's series. And remember, if at any point anywhere in the series you were not understanding or did not understand a particular question, do well to drop what you did not understand in the comment section and we will go through it. And please, if you have any other questions, drop it in the comment section. All right. So the next question says, what is the IUPAC name of this compound? CH3, CH2, CH, into bracket, CH3, CH3. A, 2-methylbutane. B, 3-methylbutane. C, 2-ethylpropane. And D, butane. Don't get scared of the plenty CH3. Let's break it down. Now, when you're naming a condensed structure like this, you have to first of all put it in a more expressed form. So we're going to write out everything in this structure in a more expressed form So we'll start with the CH3. And when you're expressing this, you need to know that the beginning and the end of a condensed structure should always be CH3. Alright? So the beginning and the end should be CH3. Then after that, any other CH3 that you find in the middle, like this one in the bracket, is an alkyl group. Alright? So you're going to put it as a substituent. I'll repeat. Any CH3 that is not at the beginning or end of a condensed structure, when you're expressing the structure out, you're putting that CH3 that is not at the beginning or the end as a methyl group. So it's going to be as a substituent. Alright, so let's get to it. CH3, this one is at the beginning of the compound, so it is CH3. It is not a substituent, but it's part of the compound. Alright, then the next one is CH2, carbon 2 hydrogen. The next one is CH, 1 hydrogen. Alright, then we have CH3. So like I said, you're putting it as a substituent, and we'll put it here, CH3. That is our methyl substituent. Alright, then finally we have CH3, which is at the end of the structure. So you need to be very, very careful to make sure that carbon does not have more than 4 bonds. So after you're joining it, you can confirm throughout the whole carbon if any carbon has more than 4 bonds, and if it does, you have to draw it again. But here, all carbons have 4 bonds and they are fully bonded. So the next thing to do is to get the parent name, and we have that there are 4 carbon atoms, right? So since there are 4 carbon atoms, then the parent name is butane, because it's only single bonds that are there. So since there are only single bonds, it is butane, right? Alkanes have the functional group of single bonds, carbon to carbon single bonds. Now, the next thing to ascertain is the substituent. There is a substituent here, which is methyl. So the substituent is going to be our prefix, which is going to be methyl, right? But now, we need to know the number to assign to the substituent. So we count either from the left to the right, or from the right to the left. You count from the side that is closest to the substituent, so that we give the substituent the lowest number. So with that said, we're going to count from the right to the left. So this is 1, 2, 3, and 4. So yeah, the substituent is on carbon 2. So the number of the substituent is 2. The name of the substituent is what? Methyl. So 2-methyl, and finally the parent name, butane. This is the structure. If you count from the left to the right, 1, 2, 3, the substituent is going to be on carbon 3. And that is actually wrong, because you have to give the substituent the smallest number. Alright? So the name of this compound is 2-methyl butane, which is option A. Not 3-methyl butane, not 2-ethyl propane, and also not butane itself, right? 2-methyl butane. Alright, last question. Which of the following is a non-polar bond? A, carbon to hydrogen. B, carbon to carbon. C, hydrogen to fluorine. And D, hydrogen to chlorine. Now, what you need to know is that a non-polar bond is a type of covalent bond. Remember, covalent bonds have to do with equal sharing of electrons, right? So in a non-polar covalent bond, there is equal sharing of electrons. Very important. So that means one party is sharing 2, another party is sharing 2. Together they are sharing 4. There's equal sharing of electrons, right? And in polar covalent bond, there is unequal sharing of electrons. So one party brings 2, another brings 4. Together they are sharing 6, but it's unequally. Alright? So which of these is non-polar? Now, you always know that when elements form bonds with themselves, it is a non-polar bond. Because if I'm forming a bond with myself, both of us will bring the same number of atoms or the same number of electrons to share. So with that said, the non-polar bond here is carbon. Carbon to carbon bond. Like I said, when an element forms a bond with itself, it is a non-polar covalent bond, because both of them will share the same amount of electrons. So we've come to the end of today's tutorial video. This is the part 2 of the Organic Chemistry series. The part 1 is already up in our channel, and the part 3 will be uploaded very, very soon. Thank you for watching. I hope you enjoyed. I hope you learned. And I will encourage you to drop any questions you have in the comment section. Do follow us for more tutorial content. Do well to like, share, subscribe, comment, and follow us as we bless you with tutorial content. Thank you very much for watching.